Welcome to Arknode Tech Review. Today we're diving deep into how Arknode.com can help you with the first LEGO League Innovation Challenge. Arknode.com is an AI research assistant tool that helps you quickly understand cutting-edge AI technology presented in the latest research papers. Let's explore and experiment with ideas for using AI in the first LEGO League Innovation Challenge. This season, the theme is Submerged. Teams will explore the ocean's layers and bring their learnings to the surface. The innovation project is a core component of the competition, challenging teams to research a real-world problem related to the theme, propose a solution, and share their findings. For the innovation project, teams start by identifying a problem. Here are some research ideas. I'm interested in the idea of marine species conservation. We'll identify endangered marine species and propose conservation strategies. My idea is to install a camera in a location where endangered species passes by seasonally. We can observe the population from the camera to determine the risk of extinction. I want to use cutting-edge AI to identify the endangered species from the camera pictures. This is an image classification problem. First, I need a dataset of marine animals to test out my idea. I found a Kaggle dataset from Google search with images of different marine animals. In this dataset, you can find pictures of marine animals that are listed in here. In the experiment, I'm only going to use the whale and jellyfish pictures. Next, I navigate to Arknode.com, click on the Research Assistant tab, and I'm going to search image classification. The Research Assistant gives me relevant papers and overviews. This one, Zero-Shot Classification. It uses pre-trained clip embeddings for the image classification tasks. This is applicable to my problem and relatively easy to implement and demo. I can look up for the paper title, copy the paper title, and go to the paper information tab. In this tab, I can find more information about this paper. Inside of the paper summary, I can find information mentioned. I can find the proposed approach in the paper, fundamental techniques used, and the existing methods, algorithms, and frameworks used in this paper. For simplicity, I'm not going to implement the exact design presented in the paper. Instead, I will only use pre-trained clip model for the classification. Now on Hugging Face, I found the clip model, and Hugging Face also provides sample code for using clip model for classification tasks. Now I'll open Google Colab and follow the sample code. I've simplified the problem to classifying between whale and jellyfish. Now let's test the model. We'll start by importing the necessary libraries. We'll use PIL for image processing, and we will use pre-trained clip model and processor from Transformer. Next, we load the pre-trained clip model and processor. We're using the specific variant. It is a good balance of speed and accuracy. This step downloads the model weights and prepares them for use. Here, we're grabbing picture from my Drive files. I downloaded the pictures from the Kaggle dataset and saved them in my Drive. Here I load a picture from the jellyfish folder. Now for the core part, we use Clip Processor to prepare our inputs. We provide the text descriptions we want to classify against. In this case, they are whale and jellyfish. We also provide the image itself. The return sensor PT argument ensures output is in a format suitable for PyTorch, which is the framework Clip used. With the inputs ready, we pass them to the Clip model. This calculates the similarity score between the image and each text description. The model returns logis per image, which represent the similarity scores. We then apply a softmax function to convert these scores into probabilities. This gives us the likelihood of the image belonging to each class. Let's see the results. The probability distribution shows us how confident Clip is in this classification. The higher the probability for a given class, the more likely Clip thinks the image belongs to that class. In this case, it seems Clip is quite confident that the image is a jellyfish. Now let's change the image to be a whale image. Now I loaded the whale image, prepare the input, run through the model to generate output, and generate probabilities. Now this image is classified as a whale with high confidence. As you can see, we can leverage the AI research assistant tool Arknow.com to find the right AI technology to address real-world problems, even in the context of the first LEGO League challenge. Arknow helps you quickly explore and understand cutting-edge AI research to enhance your projects. Please check out other videos in my channel about cutting-edge AI research. Good luck with your innovation projects.